Now we're going to talk about a kind of polygon called a parallelogram. That not only is it a polygon, but it's a quadrilateral because it has 4 sides, quad 4. Now, the easy way to refer to a parallelogram, is a tilted rectangle, okay? Because it looks like we had a rectangle that somebody pushed over. What makes a parallelogram special is that, and part of its name, is that we have 2 pairs of parallel sides. That's what these little lines mean. Because these 2 lines are parallel, if I had drawn it correctly, and these 2 lines are parallel, okay? Now, a rectangle and a square and a rhombus are all special kinds of parallelograms. Kind of depends on how you look at it. Some people argue about that, but a rectangle fits the qualifications of a parallelogram. It just has some extra added into it, okay? So with the parallelogram, not only are these 2 lines parallel, they're also congruent. They have the same length, as well as these 2 sides. These 2 sides are parallel, they're also congruent. And if we look at a rectangle, parallel, parallel, congruent, okay? Parallel and congruent. So that's how a rectangle fits in with the parallelogram. Now, before we get to the area of a parallelogram, I'm going to go to a rectangle, okay? So I have a rectangle here. And if we wanted to find the area of this rectangle, I would take my length times my width, okay? Or my base times my height. And that would give me this, the area of this rectangle. Now, to show you that I am not going to do anything, take away any pieces, I'm just going to cut a piece off. Okay? So I've cut off the corner of my rectangle. So I had a rectangle. If I take this and put it on the edge, I now have a parallelogram. Okay? So it was over here. I just moved it over here. Now, going back to the area of our rectangle. Here, let me clear this off for you. So going back to our rectangle, we said that the area was the base times the height. Well, this rectangle would have the same area as my parallelogram. I haven't taken away anything. I've just kind of rearranged some stuff. Okay? Well, that base is still along the bottom. Okay? That is just kind of split up and moved over. So all of this length is still all along the bottom. My height, however, is here. Then I'm going to separate these a little. This was how tall my rectangle was. When you're finding the area of a parallelogram, the area is the base times the height. You have to be sure you're finding what's the height, not measuring how long the side is. Okay? This wasn't our height in our rectangle. If we took that number, it would give us a much larger area. That isn't representative of this rectangle, nor is it the area of our parallelogram. Okay? So our base and our height have to be perpendicular. So you want to make sure that when you're using the 2 measurements that they form a right angle. Okay? So, looking at a problem. So, I'm given a parallelogram that this side is 28 centimeters long, and it tells me that this dotted line is 15 centimeters. This is my height. I know that because it has this little right angle here. That's what you want to look for. So to find my area, I need to take the base, so just this black line, sorry. I need to take the base times the height of my parallelogram, which in this case is 15 centimeters. So I always begin by writing out the formula, just to make sure that I get everything. So the area is the base, which is 28 centimeters, times the height, which is 15 centimeters. So, using my calculator, 28 times 15 is 420. And then centimeters times centimeters would give me square centimeters. Because again, with area, I'm looking at how many little squares would I use, how many square centimeters would I use to cover this parallelogram? Well, it would be 420 square centimeters.